Jim Bohac. Jim is the Vice President of Marketing at Forte Media. He has over 25 years of marketing and engineering management experience in the fields of wireless communications and voice processing, including positions at Stanford Telecom, RFMD, Surf Technology, and Audience Inc. James started his career as a voice processing research engineer at the U.S. Air Force Secure Voice Processing Lab. Please welcome Jim.
Put this in my pocket. Okay. So I'm going to talk to you today about how we see voice having a play in wearable devices and what role it can play, and then some of the elements that are required to make voice effective in a wearable device. A little background on Forte Media. We've been in business for 15 years, and our mission and the reason to be in business is to make voice and audio work well in consumer devices. The way we do that is with our technology we call advanced microphone array processing. We've shipped in volume to a lot of consumer applications already. We're in the Galaxy S5, we're in the Huawei Ascend. We have at least one wearable design in the Gear where voice is being used, and we have a long experience in the PC and automotive industry. The company is headquartered here in Sunnyvale, and we have R&D operations both in Taiwan and in China. And then we also have application engineering support for our customers at their facilities around Asia. So let's talk about voice and wearables. The major thing about voice and wearables is if you have a wearable that has multi-modes of operation, or if it's a device that you want to get information through, like in a Gear or a smartwatch, the best way to control that device is to talk to it. If touch was the best way to control something, I'd be talking to you in sign language now, but it's not. Voice is the most accurate way to control a device. So what are the kinds of things you need to bring voice into a wearable device? The first thing you need to be highly accurate. When Sean's son puts on his wearable Iron Man outfit and he wants to command for a missile, he's got to get the missile, not the powder puff. Okay, so that's the main thing. The second thing, it needs to be low power because the device has to be used over a longer period of time, and the other presenters have already shown that power in wearable and previous devices, you're not going to charge a lot, so there's a barrier there. And the last thing that needs to be is it needs to be flexible. A wearable needs to adapt to the user, not the user to the wearable. The wearable should be out of the way. The point of wearables is to get technology out of the way to do the things you want to do. So the things that we provide to enable those capabilities are, for accuracy, we provide noise suppression through our beamforming technology so that when you give a command, the command gets your voice only and not all of the noise around you. The second thing we provide for power, we provide a scaled approach to power consumption, or scaled signal processing. So you only provide as much signal processing as you need for the voice while you're moving forward. And the last thing we provide is a very accurate voice tracking, so you don't have to point the device to your face. So if you're running, you can just run and say if you want to change mode, or if you stop jogging, if you don't want to track, you can stop or change the mode of the thing that you're doing. So one of the key elements is, and one thing that we can enable with our advanced technology, is the ability to create a zone of interest. So if I have my wearable on my wrist, I can create a zone pointing to my face. If I don't want to get everything, we can also then track, as I move, we can track your voice within that beam. It's a very powerful technology that can be applied to a lot of applications, both wrist-worn and any other kind of wearable that you have. Low power is key to all of this. So we haven't talked about what's needed in a voice recognition system. So you really need scale. You need to scale with where the voice is being applied. So in the device itself, you probably only want to work on things like control, wake up, and those types of functions. If there's anything complex you want, it tends to go to the network. So it's a scaled system. It relies on contributions both for what's going on in the device and what's going on in the network. So for the simple things like turn off, turn on, change mode, that all should happen in the device. Even within those short commands, you can use a lot of energy to determine what the person wants to do. So the key is to only turn on a little bit of processing in the listening mode. And once you finally realize that someone is giving a command, then turn on more signal processing in a speech-to-text mode to use as little power as possible. And finally, if you exceed the vocabulary of what the device is supposed to read, you need to take that voice and send it on to the cloud, where there's a better opportunity to recognize what's going on. There's more compute power, so you conserve the power in the device. The way we do it, and this is what's illustrated here, is kind of a profile that you can have. So you want to be off as much as possible. So you can start with very low-level analog voice detection. And once you receive energy, then you can turn on varying levels of signal processing power, thereby preserving battery power moving forward. The final element is accuracy. And so accuracy comes in two ways. One is by eliminating ambient noise around you. The other is by providing signal processing to enhance the performance of whatever you're trying to control. This is an example of what happens when you go into noise. The blue line shows a person moving through different noise environments, say babble in a restaurant, being in a bus, being in traffic. And you can see that the rate goes down below 60% in some cases. So if you're trying to control a device and you only get about a 60% accuracy rate, you're not going to use voice to control your device anymore. So the most important thing is to get that accuracy rate up. And with the combination of our beamforming and our other signal processing techniques, we can bring that recognition rate back up to an acceptable level so that voice can become that effective interface for devices. So this is a very quick overview. The keys that we provide, if you want to use voice, you need to be accurate. That's the main thing. The second thing, you need to be low power. And lastly, the device needs to be flexible so that it can be applied across a large number of devices. You don't make the person adapt to the device, but the device adapt to the person. Thank you.